Hi, today I'll be talking about how we at ABAX are running and maintaining 70 plus local development clusters with K3s and GitOps. So let's jump into it. My name is Thomas Ornell. I'm a principal systems engineer at ABAX, and I'm also part of the company's architecture group. My focuses are mainly operations, CI/CD, security, and FinOps. And I'm also mostly involved in any new company initiatives going on at any given time. I like to make Kubernetes do things that Kubernetes really doesn't want to do, which also usually means that I'm doing something I probably shouldn't be doing. So, who are ABAX? We're the second largest telematics provider in Europe and the biggest one in Scandinavia. And then the question becomes, exactly what is telematics? And in the context of ABAX, telematics is tracking of assets. We are tracking things like vehicles, construction equipment, tooling, and shipping containers, and anything in between. That also means that we're processing 25,000 messages a second more during rush hour. We have devices ranging from the size of two cell phones put together down to the size of something equivalent to the Apple AirTag. ABAX has 70 developers located in 4 different countries. We also have decided to split internal IT and our customer production, the operations team, also known as the DevOps team, which I'm a part of. My team, with the exception of myself, consists of 2 systems engineers, 1 DBA, and our director of DevOps. ABAX also owns the Automile and RAM brands, Automile in Sweden and RAM in the Benelux region. In total, we're present in 11 countries, and we have lots and lots of sensitive data that we are the custodians of for our customers. We are also currently working quite a bit on how to use the data we have from our customers to do new and valuable things for them. So, in total, as the name of the talk kind of suggested, we have 70 dev clusters, all of them managed with GitOps, with K3d as the main way to provision clusters, Fleet to manage GitOps, and Rancher as the management interface. We also have 2 staging clusters, and we are running about 3,600 containers in production at any given time. That also adds up to about 2 million container runtime hours. We have 2 customer production clusters. They tend to be on the larger side. The reason why we have 2 is that we have one that is focused entirely on data ingest, because we have a lot of data ingest, and the other one is processing and the front-end interface for our customers. We have 1 production infrastructure cluster. The purpose there is to host any piece of infrastructure that is required by our environment to run, but is not directly related to our customer product. We also have a small data science environment. Our tech stack in general consists of Rancher, Fleet, GitLab for our version control and CI/CD, Datadog for observability, Aquasec for cloud security, supply chain security, and workload protection. On the cloud side of things, we have our GCP as our primary cloud, AWS as our secondary cloud, and Azure if we really have to. The approach we have when it comes to infrastructure is usually Terraform first. And since we have a lot of messages coming in from our units, we have Kafka and RabbitMQ as our messaging services. So, how do you serve 70 developers, keeping your environment secure and still being able to keep the lights on with such a small team? And there's a few key takeaways here. First one is standardize as much as possible. When you standardize things, make sure that you automate as many of them, leaving out the risk of human error, to put it that way. And then ensure that you actually have auditing on as much as possible. That will enable your developers to be able to debug things themselves, as well as making it a lot easier for you if you need to debug yourself. And to ensure that All the automated things are triggered the same way every time, again, removing the element of human error. We have invested a significant amount of work within our CI/CD pipelines. We have quite strict admission controls within our clusters. Reason for this is not to block developers from doing things, but mostly blocking people from going around processes, either be related to how we do things or related to security. And at some point, you kind of have to trust the developers. And if you can't trust the developers, at least do trust the controls you've put in place, because you need controls in place. And if it's one thing we've learned the hard way, it's that you can't control everything. What you can do is ensure that you have the best controls available to make sure that everything goes as smoothly as possible. So, okay, how do we do developer environments? I'll talk a bit about how we do cluster provisioning, the reasoning behind our choice in management interface, a bit on the infrastructure capabilities that you might need to be able to add to the cluster itself, how you deploy basically a large system onto a very small device, and the trade-offs that needs to happen there, and why we chose GitOps and especially Fleet to do what we're doing. There's also the fun topic of basically what do you do when something fails, and I'll also be demoing how we are setting up new development clusters for our developers. So there we go. And provisioning the cluster, we've decided to use K3d. There's quite a few different reasons for that. We like that it's mostly platform independent. It's easy to use. We had been using it for some of our more advanced test cases in our CI/CD pipelines. We are a heavy traffic user, so the fact that traffic comes pre-installed was also another bonus. And frankly, we don't really enjoy the way Docker, the company, are doing things. So we decided not to use their Docker desktop solution for this, further tying us into their product. And a repeat question we keep getting is, doesn't it require a lot of local resources to run a Kubernetes cluster on your laptop? And with K3d, the answer is at least close to no, not really. So when it comes to the management interface, consistency is definitely key here. The end goal for us is to have a familiar environment for our developers wherever they are actually working with Kubernetes, be it in GCP, in Azure, or on-prem, or the production environment, staging environment, or the local dev clusters. So we have decided to split out a separate Rancher instance specifically for the dev environments. And the reasoning for that is actually quite simple. In the dev environment Rancher, we have all the developers as admins. That is a requirement to getting everything to work. So since we didn't want all our developers being admins in our production environment, that means a new instance of Rancher. And then you have the infrastructure capabilities. Those are all the things that you don't really care about, but you need them to be there. That can be things like SQL Server, it can be observability testing, or it might be something as simple as Kafka. And we do everything through Fleet, basically through labeling of the cluster that the developer have. We've provided tooling for the developers to be able to add or remove labeling quite easily. They can do it either when the cluster is created, or they can label it again after the cluster creation. And to achieve this, we are using what you in Fleet call cluster groups. So these are a couple of examples of cluster groups that we have present in our environment. You have Datadog and OTel for observability, you have MongoDB, and you have SQL Server, and a lot of other pieces of infrastructure. These should be easy to add for the developers, and that has been our goal all along. And then we arrive at the question, how do you fit a large system onto a very small device? And all these dots are how Datadog perceives our production environment. All of the little dots are basically services running within our environment. And the simple answer to the question is, well, you don't. You can't put a system that requires hundreds of gigabytes of memory and almost 200 cores to be running. You can't fit that within a small developer laptop. It doesn't really matter how powerful that laptop is. So what you have to do instead is that you have to make some hard choices. And we've spent quite a bit of time defining the borders on our business domains, basically. We also quite quickly discovered the fact that you have some pieces of software, especially legacy, that isn't easily fitted within the dev laptop. So in some cases, those are running on a shared instance that basically all our dev environments are using if they need it. Other than that, the selector works the same way as they do with infrastructure. The developers has a choice if they want to use a shared database instance that we are hosting for them, or they can spin up their own database within their own local cluster. Again, you probably don't want to run a very large database instance on your local dev laptop. And again, same as with the infrastructure, you can add or remove functionality at any time. And these are a couple of examples of business domains that our developers can be adding. And then the question becomes, and I hear this quite a lot, why did we go with GitOps? And the answer there is quite simple. Developers go on vacation. Some bring their laptops, some don't. In a lot of cases, the laptop is off, meaning that we don't want to have a push-based system. We want it to have an eventual state. So when a developer comes back from vacation or extended leave, if we've done changes to the configuration of the infrastructure or any of the business domains, it will be automatically updated within their environment unless they've actually locked the version of the deployment. Having everything in Git as well gives us a huge advantage when it comes to auditability, making it easier for the developers to detect changes we've done and other developers have done as well. And then, and then there's, well, something has gone wrong. What happens now? And we are encouraging our developers to basically remove the components that are failing and try to re-adding it. Basically an advanced version of have you try turning it off and on again. If that doesn't work, we actually are encouraging them to remove the cluster and re-add it. That takes away a lot of work on my team and lets the developers handle most of the things themselves. In the cases where that doesn't help, then more than likely the problem is much bigger than local dev laptop, so we are more than likely going to need to be involved anyway. One usual comment we get to this statement is, well, doesn't it really take a lot of time to set things up again if you need to remove them? And the simple answer is not really, no. Everything is scripted. The developers can do this in just a span of a few minutes. And our main goal has been to make everything as easy as possible for them to be able to do it. And since I'm brave here, I'm going to do a live demo of exactly that. Starting in a terminal, all you really need to do is type new cluster -- simple. That is a plain deployment of K3d with no additional labels added. I do this now because I want to show you how we can label things afterwards to keep things simple. So I'll start provisioning here. And this is going to take about 3 minutes to set up. If we jump over to the Rancher interface, The new cluster should show up in a moment. There we go. This will be pending until it's done downloading all the Docker containers that is required for this to run and the whole registration process to be completed. While we wait for that, I can jump over to continuous delivery or fleet. This is the fleet dashboard. It shows all the Git repos that has been set up and the deployment status of all of them. I mentioned cluster groups earlier, and these are the cluster groups that's been set up in our demo environment. You have examples of business domains. I named them creatively domain 1 through 4. I've also added infrastructure components like Cert Manager, MongoDB, SQL Server, OpenTelemetry Collector, TestCube, TraceTest, and Traffic. So, going over to the Git repos, you can also see the actual Git repos here, and you can see the configuration itself. Currently, we're still waiting for the cluster, so there's no clusters here for now. If I go back into cluster groups and have a look at domain number 1, and I head over to configuration, I should be able to see that it's looking for clusters that's been labeled with domain 1, and it needs to have the value y. These can be specified exactly how you want them yourself, and it's basically just part of the setup process of the cluster groups within fleets. Heading back to the start page, we'll just have to wait a little bit longer until the cluster has been provisioned. With the cluster now provisioned, let's go into the cluster and verify that it's empty. Heading into workloads, I have selected only user namespaces, and do note that there's nothing to show here. I'm now going to do something about that. So let's head into continuous delivery, and my plan is to deploy domain 1, domain 3, and MongoDB, which is one of their dependencies. Heading over to the terminal, the command is label cluster, and then it's the key value, comma separated. So running that, the cluster is actively being labeled. And you can tell now that multiple clusters have been marked as unready. Heading over to the Git repos, you can tell that they are actively working on being deployed. If we re-enter the cluster, we should start to be able to see what is being deployed. And there you go, domain 1, domain 3, and MongoDB. Let's say I'm done working with domain 3. Head back into the terminal, label cluster, domain 3, and no. Heading back into Rancher, domain 3 is now gone, being removed by Fleet automatically. Next step, I'm done working on this project entirely, and I want to do a full cleanup, or I need additional resources available on my laptop. Then you head into the terminal and you type delete cluster. And there you go. The cluster has now been removed, and you're ready to go for your next project. At ABAX, we enjoy giving back to open source projects, be it either providing feedback to the maintainers and creators of open source projects, reporting issues, in some cases providing code. But in this case, we couldn't really find anything out there that did what we wanted to do. So what we've done instead is that we just open sourced the scripting we are using to create our environments and set up the dev laptops. And that is available from today. So I hope you guys will enjoy this one as much as we are enjoying other open source projects. And with that, I would like to thank you guys. Thanks for your time, and I hope it